Hey, so for our project, we decided to make the AI Detector. It's a pretty advanced model that can detect articles of technology in everyday scenarios, including airports, stores, and classrooms. Our project was created by 8 high schoolers who are passionate about this concept. Those people are Peter Dickinson, Nishchay Jasuja, Theo Zak, Jaywu Jun, Brandon Lee, and Donovan Fox.
We decided to make this project for many carefully thought out reasons. Our first reason was we felt that our project would assist in the process of identifying and stopping even a small portion of the millions of tons of e-waste the world generates every year. Preventing this e-waste even slightly would prove to be very beneficial. Our second reason was to help schools identify students sneaking in electronics that they aren't supposed to, which would help prevent cheating or any other inappropriate use of electronics during school. Finally, our last reason was to assist airports in scanning electronics in the luggage that people bring into airports. Identifying which electronics there are would provide safety and would be efficient in identifying the electronics brought onto the plane.
For our data, we needed to collect about 500 images per device we wanted to detect. We had 2 main sources of getting this data. One was using pre-made data sets or groups of images that someone else had compiled, or scouring the web for our own images. Mostly we had to scour the web for our own images, but we had to look for 2 things. One, the image had to include more than 50% of the object we wanted it to detect. You can see this in the 2 examples. You can see the whole keyboard in the first one, but only about a third in the second one. That would be bad data. The second one was that the images had to be unedited. In the first one, it's just a tablet on someone's table, and someone just took that picture. So that's how it would appear in the real world. But in the bad example, a graphic has been added on top, which isn't how a tablet would appear in the real world, which would mess up the AI.
Okay, so as Peter mentioned, we had to collect a lot of data. I'm really sure a lot of other groups had to. And it was one of the most arduous processes of the whole program. And then after we collected the data, we uploaded the data to a website called Labelbox, which is a tool that we use to label the data. Basically, in every image, we labeled the items in the image among 6 categories: tablets, phones, laptops, headphones, keyboards, and controllers. And you can see how many of each image we labeled right below. And now, as Peter mentioned, we labeled 500 plus images for each category. So you might be wondering how there are 1,000 tablets and only 454 controllers. Well, one thing we found is that some images, which looked pretty high quality when we first glanced at them while collecting, when we had a more in-depth look while labeling the data, they didn't turn out so good. And a lot of images had multiple phones, multiple tablets. So even though there were 500 images, there were 1,000 tablets in these images. So once we finished labeling the data, we then started coding. Basically, there's a lot of data and we need to make sure that we can upload it and train our model with it. So we wrote scripts that copied the data into our CodeCalc center, and then those scripts prepare the data by generating the yellow coords, and then it split the data among 3 categories: a training set, a testing set, and a validation set. So the training set is the set that we use to train the model. A testing set is the set that we use to test the model after we trained it. And the validation set is the set we use to evaluate the model near the end. So what we did is that we chose an 80-10-10 split. And what that is that we took 80% of the images and put that in the training set. 10% of the images goes to both the test set and the validation set. Okay, let's just forget that. So with our data fully loaded, fully prepared, and fully split, we can now move on to using our algorithm to do something pretty cool.
So just like a lot of other groups that used computer vision, we used the YOLO V4 algorithm. YOLO stands for you only look once, and it's a lot more efficient than a lot of other CV algorithms. We used those 6 categories that you might have seen before to label images and train the model using those labeled images. We also used the well-known IOU algorithm, which stands for intersection over loss, as the intersection over union algorithm as our loss function during the training process to navigate this n-dimensional space to find the best weights. In the end, we used a 7x7 confusion matrix to see the results of our training and how accurate it got.
Finally, we made a website to house and display our product. On the website, we just have a homepage, which with like boxes that you can click to show what we went over with our Google Slides. And then you can also test the product with some images that we compiled. So this one is a bunch of phones on a stand, and it detects all of them. There's a lower confidence for the phone that's in her hand because there's not that much of it visible. And then it also talks about it. You can see which ones are less likely to be accurate. Like a tablet might detect a phone more often, might be detected as a phone more often, given that we only had about 3 weeks to train our model.
So do you guys have any questions or any images that you want us to test? Dang, I mean,
let's give them a round of applause first. You know, it looks like they're building something maybe for the teachers to catch us using cell phones, you know, by this image suggests. But regardless, this is pretty cool stuff. This is pretty cool stuff. Yeah.